Excellent. So I was asked to be inspiring. So the good thing is that this will be a fairly short presentation. A quick intro to Amplify. We are based in Cardiff. We are effectively, I guess, we're classified as a small company now. We founded the company back in 2015, and at the time we were thinking about where we base ourselves. We're looking at Silicon Valley, San Francisco. We were looking at London and Berlin, even visited Beijing. And in the end, we opted to headquarter in Cardiff. And you've already heard from some of the great institutions, some of the great universities, and some of the academic initiatives that are underway in and around the South Wales region. And when we were thinking about this back in 2015, that was the primary driver for us choosing Cardiff. We could see the ambition that was going on, and we looked at, say, London and Silicon Valley, and we looked at the competition for talent, and just thought, we will get the pick of the top talent coming out of these initiatives in AI and machine learning, and full stack developers, etc. So that's why we're based in Cardiff. What I'm going to cover just right now is basically focus on kind of where we specialize in. So Amplify, we specialize in, we're very definitely B2B, and it's all about enabling organizations to improve their business intelligence and their research, and we do this by unlocking the internet. So I'm going to cover off three areas where we have strong capability in. I'll give you some practical examples of where we're starting to take our tech and apply it to what I think are for good. And if nothing else, as part of this conversation, I hope to leave you completely disappointed with Google if you're not already. But the three areas I want to focus on in terms of capability is one, going beyond the surface web. Secondly is how we generate insights from unstructured data and what you can achieve if you do that. And then third is the work that we're starting to do around removing what I think is the last barrier in terms of unlocking the internet, which is removing language barriers. So first off, there's a big thing out there called the internet, and it contains lots and lots of information. Now, the internet broadly consists of three layers. There's what's called the surface web, there's a deep web, and there's what we call a dark web. Now we don't go to the dark web. There are specialist outfits out there that will go to the dark web and analyze the information there, but we focus on the surface and the deep web. The surface web is essentially that part of the internet that's been indexed by standard search engines such as Google, Bing, and Yahoo, etc. So if you're using those tools to access the internet, you're only getting into a tiny part of the internet. The deep web is significantly larger. Nobody knows for sure how much larger, but let's say it's 500 to 600 times larger than the surface web, which means that there's far richer data content hidden there. And to access that part of the internet, you need specialist search engines. Search engines that will take you to sort of unindexed sites, to databases. We even can go beyond, providing you've got a subscription, we'll access subscription services and content behind paywalls, etc. I'm going to ask Marie to take me out of the presentation, and we can do a demonstration and show you essentially the difference between the surface and the deep web. So hopefully you can see my screen now. And I've set this up in the interest of time, but I've gone to Google and I've done a search for artificial intelligence. And you can see that. We're not seeing your
screen yet, Ian. Sorry? We're not seeing your screen yet.
Oh, that's because I need to share it, don't I? So you should have invited the CTO, not me. Here we go. Hopefully you can now.
Loading. Grand, we got it.
Excellent. Right, so here we are. We created this thing called Google that everybody thinks is fantastic. And what I'm going to show you is essentially the difference between a search engine, which is effectively an answers engine, and a research engine. So I've searched for artificial intelligence, and you can see that Google's given me nearly 900 million results. and it's generated those in about just over a second. And what I'm doing is paging through. What I'm going to do is show you the very last page. So we're going to look at the 891 millionth result, and we do that, and you can do this for any topic or subject, to be honest. You come down to the bottom of the page, and you click on the last page available. So we're now at page 18, and so what, 20 results per page. This is going to take some time. So the fact we're running a bit ahead of time doesn't matter, because we can easily absorb up the remaining half an hour or so. I come down to the bottom, and suddenly I can't go any further. I've reached page 22. That is the end of Google, literally and metaphorically. So we come back to the top, and we can see that Google now has changed its mind. It's not prepared to show me 900 million results, because it doesn't have 900 million results on the topic of artificial intelligence. It's only prepared to show me 431 results. If I'm looking to research artificial intelligence, the maximum amount of results, and it says there's about 431 because there'll be duplicates within this result set, then this is not a great tool for conducting research. So that's what you get if you go to just the surface web. If you go to the deep web, and here's an example. This is our search engine. This is our version of Google. We call it Deep Research. And if I do that same search, so this will take a few seconds to run because the machine is physically going to the internet and finding content. There we go. We can see that pretty quickly we're up close to 29,000 results on the topic of artificial intelligence. What's really quite neat, this is what you can do is if your business model is different to Google's, is that you can allow users to control and optimize results and start to delve down into results really quite quickly. So let's say I'm just interested in academic results, patent results. Now I can narrow the actual results down to just the content or results that just relate to academic and patents. I can optimize results based on the relevance or the dates. I can even translate results into a different language. But crucially, on the right-hand side here, what the machine has done is visited these sites and read the title in the first paragraph, and it's extracted from their key terms and topics. So it can enable me to drill down and explore. So if there's an area I know nothing about, just working my way around the topic wheel, I can learn really quickly about a new area. What I can do is click on, say, neural network, and you can see that I've gone from 29,000 results. By screening by source type, I've gone down to about 5,000. Now I'm down to about 227 results. So I've gone from all of the results to those sites and results that contain neural network. If I then click on convolutional neural networks, and let's say natural language processing, you can see that I drilled down from 29,000 results. I've gone down to just 4 now, and I can go back up to the top, and I can go down another route if I'm interested, or if I've learned a new topic, start another search. So that's essentially the difference between the surface and the deep web. Much more information, and because we're B2B, we can enable the user to take control and actually find information. So this essentially is what we call a research engine. This is one of the products that we developed. So I'm going to stop sharing and go back to my slideshow. If you could fire up the slides, that would be great.
They're on their way.
Okay.
Just a little delay. That was a quick review of everybody else's slides as well.
This didn't happen when we tested it.
Okay, we're just having a little trouble. They seem to have disappeared off of the platform now. As you say, we've got plenty of time, so just ask you to have a little drink of water. And we're going to get the slides back up any second now. There we go. Here they come. Sorry for the delay.
No worries. So in terms of improving research and business intelligence, going to the deep web means you're going to get a far richer content for you to analyze. The second thing that we specialize in is using machine learning to analyze and create insights from unstructured data. So broadly, data falls into kind of three categories. You've got structured data, which is very traditional. And in the area of business intelligence where we operate, you've got traditional data providers, sort of Moody's, Reuters, S&P. I'll show you some others coming up later, but things like Crunchbase and PitchBook, etc. These guys really work in the realm of structured data. And the holy grail of business intelligence right now is getting to grips with unstructured data. And the reason you want to do this is, as we've just demonstrated, there's more information out there than you'll get just through standard search engines, but also a significant portion of that data, probably about 80% of it, is unstructured in nature. There's kind of a midway house here, which is semi-structured data. The example I've given here is LinkedIn. So if I was to point a machine at certain fields, I could tell the machine that if you go to this field, you'll get a person's name. This is their position. This is the company that they work for. If you go to this field, you will find the dates for which they work for that company, etc. But then there's a field which is essentially their job description, and who knows what. If it's anything like my LinkedIn profile, it's a complete work of fiction. Who knows what could exist there? So that's kind of unstructured in nature. That there are no rules that govern how it's set out and what that field might contain. So we specialize in unstructured data, and I'll give an example coming up later about what you can achieve by working with unstructured data. But to do that, we use a lot of unsupervised learning techniques. So we use a range of machine learning, right through from sort of topic modeling to unsupervised learning, pattern recognition, etc. And it's purely in NLP. So we're analyzing content, written content. But the reason you want unsupervised learning is to unlock the unstructured data. And for those organizations that are really worried about where the next disruption to their industry is going to come from, where the sources will develop from, is it going to be technology led or business model led? You really want to discover what's called unknown unknowns. Those real left field events that you won't spot using structured data. So to get those early signals, and I've got an example of that coming up of work that we've been doing. You need to get to grips with unstructured data. You need unsupervised learning to do that. The trade-off with that, the downside to that, is there will be a lot of noise in the results, a lot of false positives. And I'm not going to pretend that our analysis is completely clean, but we're constantly developing models and the algorithms to try and remove some of that noise from the data. But that's the trade-off. If you want a completely clean data set, then you're not going to discover those unknown unknowns. With supervised learning, you're essentially saying to the machine, tell me about this company I already know about. With unsupervised learning, the machine can report back to you all what it thinks are organizations based across a very large corpus of documents. Now, not all of those will be organizations, but there will be organizations in there that don't exist in sort of company's house type data, privately owned companies, etc., that are hard to find. That's how you find your unknown unknowns. The other thing that we're now starting to get to grips with is multilingual capability. So you can see on our research engine, our search engine, that I could translate those results back into different languages. We developed demonstration tools that enable us to monitor global news across different languages, but translate them back into any modern language, to be honest. And to be honest, that's how we were. Within Amplify, we were monitoring events across Chinese news as coronavirus started, or COVID-19 started to unfold, really back in early January. So we had a sense of kind of what was likely to be hitting our shores. And as a result of that intel, we actually closed our office down about 2 weeks before the rest of the UK formally did, and started remote working, which means we were ahead of the game in terms of testing our ability to work remotely. But interestingly, if you're starting to get with analysing multilingual content on the internet. The majority of the users in terms of the language they speak, you can see there on the left-hand side, English and Chinese. But when it comes to content, interestingly, English language content forms about 60% of the content held on the internet. You can see that Chinese, simplified and traditional, is down there at the bottom, or number 10, sorry, at about 1%. So this kind of tells me that either English speakers put more content and set up more sites on the internet, or non-English speakers tend to prefer to put content up in English, or more likely that if they put their own, say, a Russian language website up, they'll put a foreign language version of that same site up, and invariably it will be English. And the clear message here, kind of, if you want your 80-20 rule, then you've got to get to grips with just the top 5 of those languages, and you're accessing and working with about 80% of the content held on the internet. I'll show you briefly what can you achieve if you bring together those 3 capabilities: the ability to go to the deep web, to work with unstructured data, and to work across multilingual capability. So this is outputs from a collaboration that we have underway with the Center for Security and Emerging Technology. This is a think tank based out of Georgetown University in the US. This has now morphed into a multi-year, multi-million-dollar project. But the challenge, the exam section question they set us, this was about a year ago, was Stanford had recently published a paper in Q1 of 2020 that looked at comparing the amount of money that the US invests in AI compared to China in 2019. And this has become like the de facto paper that looks at that makes that comparison. And Stanford based all of its analysis of Crunchbase data. Crunchbase are one of those traditional structured data providers that I spoke about earlier. If you look at the comparison, and what we did was to take our core tech and develop it to work across Chinese language documents, so simplified and traditional Chinese language documents. And we asked it to find within those documents investment events that involved companies that were connected in some way, shape, or form to AI, extract the investment event the amount, and who was the investor. If you look at the comparison there between traditional data providers, Crunchbase, PitchBook, Capital IQ, and Juicy IT, who are a Chinese data provider, if you were to search any of those platforms for companies involved in AI, you had at most 13 different flavors or types of AI. So is a company involved in natural language processing or computer vision, voice recognition, etc. We actually developed a taxonomy of it's actually now over 150 terms. So we can start to segment companies by 150 types of or forms of or elements of AI. Also, if you turn to that and those databases, those suppliers, you can see that Crunchbase has about 1,000 Chinese AI companies. PitchBook, 866. I didn't have the number for Capital IQ, and Juicy IT about 20,000. We were able to extract from the content, and it was about 1.5 million open source Chinese language documents that we harvested and analyzed. We discovered 37,000 Chinese organizations that were involved in some way, shape, or form with artificial intelligence, developing AI, and within that, some 87,000 investment events that they were involved in. So you can start to see that we were able to build not a complete picture, but a more representative picture of investment activity into AI happening in China, and significantly more information and insight you'll get from using than the standard structured data providers. And Georgetown actually did their own exercise prior to engaging us, and they found about 4,000 Chinese entities. Not only did we find the entity, that we were able to verify that it actually was an entity, and we also found any kind of sort of nicknames or acronyms that they're associated with as well. Those 87,000 investment events that we discovered, that was filtered. So we had a rule that said that the investor, the investee, the investment event, the date, and the amount had to occur within 3 sentences of each, or be contained within 3 sentences. So if you were to widen that, then you start to introduce perhaps a bit more noise and errors, but the number goes up. There'll be far more than 87,000 investment events. And then interestingly, we did the same exercise, but across English language documents emanating from the US, and we discovered that we could quite quickly get more than 10% more companies, US companies involved in AI than you would using Crunchbase or PitchBook or Capital IQ. So you can start to see this is the value of getting to grips with unstructured data, going to the deep web, and working across multiple languages. I've now got, I think it's 3 examples of how we're starting to take our core tech and apply them for what I think are good uses. And I would argue that our search engine is kind of part of Tim Berners-Lee's effort to try and democratize the internet. One way in which we're starting to use our core tech is to develop new global indices, particularly around benchmarking and measuring corporate performance against environmental, social, and corporate governance metrics, so ESG. And here, this is the first cab off the rank. This is our first example where we focused on carbon neutrality, or achieving, or ambitions, aspirations to achieve net zero greenhouse gas emissions, ideally by 2050. But a number of outfits have announced ambitions to get there sooner, sort of 2030, 2035, etc. And here again, we're using the tool to analyze open source content. At the moment, this is purely working across English language, but we can build this out to work across, well, technically all modern languages. And there are outfits out there. You have your Dow Jones, you have Refinitiv, etc., that already produce ESG metrics and scores, but they have a number of limitations. First off, they have large teams of people putting this information together. I basically pressed a button to get my results. They're relying on organizations to self-assess themselves. So you can imagine the quality of the results that come back. They're relying on annual reports or annual sustainability statements, etc., to be published. So these scores, these metrics from your standard data providers only get updated annually, whereas we can update these on technically on a daily basis, but ideally probably monthly, quarterly, etc. And we create an index. Other ESG index says a kind of a percentage score. And once organizations figure out what they need to do to achieve 100% score, and once you've achieved that, you obviously can't improve upon it, you can guess that sooner or later, a lot of organizations will be maxing out at 100% or getting pretty close to it once they've learned the rules of the index. This is different. So this measures the strength of the dialogue connecting organizations with topics around carbon neutrality. We can roll into there the sentiment that surrounds that dialogue. So it becomes very difficult for a single entity to manipulate the global discussion around itself and key elements relating to ESG. And given that investors increasingly put in emphasis on ESG, markets are valuing companies based on ESG metrics, and even consumers, the public are starting to do, that to some extent that buying decisions, their opinions of organizations will increasingly be shaped by ESG scores. So what we're attempting to do here is to produce an index that's driven purely off unstructured data. It's machine driven, so it's as unbiased as we can make it, and it's truly global. The final example I'm going to show you is this was a project that we completed early this year, ended in February. And this was a small project funded by UK IRI, who we've heard from previously. And this was a call that they issued for ideas to address the COVID-19 pandemic. It was a short project, about a 5-month project, and I kind of scratched my head to think about how can we apply our tech to this call. And I kind of thought, well, the pandemic, COVID-19, is the horse has bolted. what could we do about the next pandemic? Because that's what we should be worried, concerned about. And so I began to think about, well, would it be possible to use our tech to create an early warning system? And one thing we had to sort of come up with was a way of saying, okay, if we had early warning to COVID-19, what would that be valued at? And experts sort of, basically come out and said that the delay in China releasing the genetic sequencing of COVID-19, every single day that they delayed releasing that was an opportunity lost. If they'd released it to the international community, then we could have understood what we were likely to be up against sooner. Could have started working on vaccines sooner. We could have started ordering in PPE equipment, etc., ventilators. We could have been shutting down our borders sooner. And those experts say that every single day was an opportunity lost. So I looked at OECD analysis of the UK economy, and basically for every single day of lockdown, every single day that the economy has been in lockdown, the UK GDP has suffered about a 2 billion loss per day. If I looked at the UK furlough scheme, the job preservation scheme, depending on kind of whether you assume everyone on the scheme is working full-time or part-time, that's costing the Treasury about £400 to £600 million a day. So the argument goes, if we could have got even 1 day's warning, then the costs would be phenomenal. So that was the application, and the idea was to say, could we build a tool that, and this was a technical demonstration, could we build a tool that was constantly analysing open source content on the internet real time, and flag up as perhaps a traffic light system or a red flag if it sees the potential for a new pandemic breaking out. So it's not a forecasting system, it would be an early warning system. And the way we did this was to, we harvested, again, it was English language only. We harvested about 4 million documents. We had the machine look and analyze for 25 known zoonotic diseases. So a zoonotic disease is a disease that occurs in animals, and it mutates to jump across species, and eventually mutates sufficiently to jump to humans, which is essentially what, in theory, COVID-19 did. It's a form of coronavirus, which is a subset of zoonotic diseases. But there are thousands of these diseases out there, and plenty of historic examples of this happening. But we also thought, okay, what we can monitor for known diseases, but what about unknown diseases, so new diseases that haven't jumped yet? So we had 2 work streams, and essentially what we did was to build taxonomies of topics. So for every disease, every run that we did, we were generating thousands of topics. In total, over 24,000 unique topics we identified and modeled. And we basically looked across each of the runs and started to distill, are there common patterns across those topics that are common to all of the runs, most of the runs, or the majority of the runs? And if so, and we looked at each of the topics, and the machine effectively showed us how each topic had trended over time. We've now come up with a set of topics and their related trends that you have the machine monitoring and say, if you start to see these patterns repeat themselves, then I'm not saying that there is going to be a pandemic, but history looks like it might be repeating itself. And so an example I'm showing here is we did a run on coronavirus, and it found this topic called palm civets. Palm civets was the cause of the outbreak of SARS in China back in 2002. Animals being sold in a wet market containing a coronavirus that jumped to humans because they were being consumed. Very similar story to allegedly for pangolins in Wuhan in a wet market in China in 2019. But when we look at that trend in palm civets, you can see that at various points in time, this is a machine-driven trend from unstructured data. So the machine has found the topic palm civets, and it's quantified how it's trended over time. You look at the peaks, and you can see that the trend peaks at 1 to 2 years ahead of outbreaks of known diseases like the Middle East respiratory syndrome in Saudi Arabia, Ebola. There was an outbreak in Guinea in 2013. You can see the topic peaks in 2012. Another outbreak of Ebola in Congo in 2018. Topic peaks in 2016. big peak spike in 2018, COVID-19 in 2019. Now, I'm not a conspiracy theorist, but there are virologists, there are scientists, there are centers for disease control and prevention that are constantly monitoring for these events globally. So that raises a question of, was there something out there in open source content that could have given a signal to a potential pandemic event occurring? So this was a project, like I said, we completed at the start of the year. It was a proof of concept. To take this further, it would require a consortium, significant amount of funding. We need to work with virologists, experts in zoonotic diseases, the Centre for Disease Control and Prevention, etc., to get international buy-in. We would need to build the tech out to work across multiple languages. We already had that capability. But this is, I think, is a great example of how AI could be applied for good going forward. And I think that's a lot. Yeah, that's it. That's me done. Happy to field any questions, or I'm available to connect with on the platform later in the day if anybody wants to chat further. Hopefully that was inspiring.
As we requested an inspirational talk, I'm a bit scared to ask the very obvious question about the study that you showed us. When do we need to start stocking up on toilet roll and pasta again?
I'm always stocked up on toilet roll and pasta.
Have you got any kind of ideas of when this is going to hit us again, if there's something on the horizon?
Like I say, it's not predicting. So all I can say is nothing imminent based on kind of what we were seeing. But you know, if we were to build Zeus out and have it sitting there literally automatically scanning the internet, processing information, I truly think you can get to a point where those signals will emerge, and all it's doing is raising a flag to say to experts, I think something's happening in this part of the world. You might want to go and ask questions or research or explore. Yeah, absolutely.
Okay, well, thank you. So Tashi has a question. So does Google know what you know, for example, around the deep search? How are you protecting your work, AI for good, and leading innovation in this field?
Sure. So in the really early days when we were just starting out, we were actually using search engines like Google and Bing. And when you set the crawlers working, Google definitely knew you were doing something interesting. So they deliberately slowed you down, and the phone would ring, and they were keen to know what you were doing, and you would sort of put the phone down. I'm pretty sure that they're aware of us, but we're not a competitor, and they're not a competitor to us, because they're B2C, that they've got a completely different business model. I would say that one of the sources of value for our clients using deep research is, you know, not only do you get into more content and you can work your way through that content quickly in a way that Google doesn't allow you to do, and you can optimize results in a way that Google don't allow you to do. Interestingly, if you go to the Telegraph website and search the Telegraph's website, you will see that their search engine for their website is supplied by Google, and there you can optimize results by date or relevance, and that shows you what you can do if you pay Google to do it. So they can optimize, but they don't, because it would impact their business model. So they're B2C, we're B2B. And the third sort of value for us is anybody using deep research is anonymous online. So Google knows it monitors what you're searching for, it's learning your behaviors, etc. So we actually help to protect our clients' IP, if you like. How we protect our work, we trying to put in patents in place for software is incredibly difficult. It's incredibly expensive. You need a really good, expensive attorney to do that, and we're not in a position to do that right now. So we rely on trade secrets and copyright, etc., for our products. And leading the innovation in this field, you know, we are working, I think, at the bleeding edge of AI. But I would also say that For me, a lot of people confuse the term invention and innovation. So invention is essentially coming up with developing something from first principles. Innovation is commercializing that invention. And I think what we do, given our co-founders' background, is we're strong on both the technical side, the invention, and also the innovation. And my background is certainly not technical. Neither is my co-founder, Chris Ganges. It's understanding what those commercial pain points are in those big corporates. It's understanding, where the next frontier of data and business intelligence and research is. And we've chosen the internet. We're already thinking about where next, where beyond the internet. So it's constantly about, it's the commercial, it's our commercialization strength, I think, is where we lead is actually the practical application of AI.
Hooking them in, finding your niche and hooking them in.
Yeah.
Fantastic.